Hello, everyone. Welcome to your second lesson of the week. This lesson, we're going to go over key features of parabolas that you've been talking about. My name is Mr. Bolio. So we have three graphs here on the right, and I would imagine at this point, you guys could identify which one the parabola is. If you think the red graph is the parabola, you're correct. And we know it's a parabola whenever the equation has a y equals x squared as the highest exponent, or x to the power of 2. Now this graph might actually have other things going on, like it might have a quadratic coefficient of 2, maybe it has a linear coefficient, and maybe even a constant at the end. But really what we're looking for to identify that it's a quadratic and its graph is a parabola is the x to the second power being your highest power. If you have an x to the third power in there and an x to the second power in there, the graph will not be a parabola. It'll look different. Now, what about the other graphs? Let's think about that blue graph. What type of graph is that? Yeah, that's a linear. Y equals mx plus b. We did that earlier in quarter 1 and quarter 2. And what about that green graph? If you think it's an exponential, you're right. Y equals a times b to the x power. That looks like exponential growth. Those are the three main functions that we've talked about this year in Algebra 1. Now, Mr. Averill taught you that whenever we have an equation in the form y equals ax squared plus bx plus c, that's a quadratic equation, and its graph will be a parabola that either opens up or it might even open down. What we would like to talk about today is the parts of this equation. So the first part that I want to talk about is the a. What is the a? The a is the coefficient, or the number in front of x squared. It's what we're multiplying x squared by. And we call that portion, since it's with the x squared part, the quadratic coefficient. What about the second part? Well, let's look at the letter b, which is next to the x. The b is the coefficient of x, and that's the part that we call the linear term. In other words, if the ax squared part was not there, it would just be of the form bx plus c. That'd be a linear equation. And lastly, the c part, we always call that the constant. Typically, that's just a plain number like 7 or 4 or -6. The graph of a quadratic function is called a parabola. We've already said that a couple times. And what did you guys learn in the first couple of lessons? If the a value is bigger than 0, which one is it? Is it going to be a parabola that opens up, or is it the parabola that opens down? If you think it opens up, you're right. And it looks like a U for up. And if the a is less than 0, like a negative number, then the parabola opens down. And it looks like a mountain. For this last part, we're going to identify the key features of a parabola. In this case, I've already graphed one in Desmos, and it looks like it's probably a parabola that opens up, so the a value would be positive. And I'd like to talk about a couple key things. The first thing that we talk about is the vertex, and I've always thought of the vertex as the most important point on the parabola. It's kind of where both sides come together. In this case, the vertex is a minimum, or the lowest point on the parabola, and the actual coordinate of the vertex is 2, -3. Oh, I think I've already answered the second part. In this case, the vertex is a minimum because our parabola opens upwards. The tricky one is the axis of symmetry. Well, what does it mean to be an axis of symmetry? Axis means a line, and symmetry means the same on each side. So we're looking to draw a line in the graph where it's the same or symmetric on each side. I'm going to draw the line right here, right down through the vertex of the parabola. What is that line? Well, let's think about the x value that that line passes through. The x value it passes through is 2. Every point on that line has an x value of 2, and the y values are all different. So the equation is really just says x equals 2, and it doesn't matter what y is. That's the equation of a vertical line that passes through the x-axis at 2. Next, it asks you for the x-intercepts. Well, I'm going to have to do a little erasing here of this line because I went through one of them. There we go, that's better. So the x-intercepts are where the graph crosses the x-axis. This parabola crosses the x-axis twice because it's symmetric. And it actually crosses at 2 coordinates. One of them is 0.268, 0, and the other is 3.732, 0. A lot of parabolas have 2 x-intercepts. Every now and then you'll find a parabola with just one. Maybe we'll talk about that later. Or none. Maybe when the parabola is graphed above the x-axis and still opens upwards. What about the y-intercept? I bet you can figure that out. Yep, it's where it crosses the y-axis. This parabola crosses at 0, 1. On the next slide, I have an example just like what I've done, but I'd like you to try to answer the questions on your own. If you'd like to jot them on another piece of paper, that's fine, but pause the video because I'm going to go over the answers. Pause the video now. All right, here are my answers. First of all, the vertex is at -2, 5. This vertex is a maximum. The axis of symmetry is x equals -2. Your x-intercepts are -4.236, 0 and 0.236, 0. And the y-intercept, where it crosses the y-axis, is at 0, 1. Thank you for watching my video about key features of parabolas. Before you're done, please complete the exit ticket on key features of parabolas in your teacher's Google Classroom page. Have a great day.